Okay. So while you're scanning the QR code, I will be asking a couple of questions for you. I will be asking the questions from the different uh, topics. So VLANs, right? This is Huawei section 1. So, okay. So between switch and the end device, which port is supposed to be configured? Access? Yes, that's correct. My question was not proper, but you understood. Okay, here's the thing. So the computer is sending some kind of messages to the switch, and switch has a default VLAN 10, and it's an access mode. What's gonna happen with this frame? By the way, this frame is tagged or not? It's not tagged. Okay. Once it enters, what's gonna happen? Okay, it's gonna tag with 110. That's correct. Okay. Example with the same frame, now leaving this port, and this port is in track mode, has a PVID equal to 10, and it's allowing the VLANs 10, 20, 30, and 99. So what's going to happen with this frame once it's going send out from this port? Let's say this port is gigabit 01. What's going to happen? Okay, it's gonna be allowed because it's in the allowed range. But how it's gonna be? Actually, because the PVID and the frame tag is the same, the tag will be removed and it's gonna be without tag. So PVID, the reason of the PVID is to transfer untagged frames. Untagged frames. So probably maybe because we want here some device, I don't know, to send this untagged frame or something. That's the reason. Okay. Or maybe there's a computer is connected, I don't know. And not the computer, maybe there's some servers connected, and the servers accept both VLAN network and some VLAN network. Also, they accept, because you know how the servers usually, it's like one big server and they have only one IP address, right? But inside we have different port numbers. We do have some, I don't know, some HTTP server, right? And then we might have FTP server. We may have many other tools, but we are just speaking only for one address. So one address, for example, right? So in that case, maybe some of them need to have untagged frames. Some of them have tag frames and so on. For that reason, we can actually use this knowledge. All right. I don't know. The address is all right. So okay, we have one more minute, so that's why I'm gonna ask you one more question. So, what is the difference between hybrid port and the triangle? Do you have any understanding? They actually do have a PA. They have a allowed VLAN range, but they have two range. So it's divided by tag and untagged. So tag is like, let's say 10, 20, and 30 and 99 is going to be untagged. So what does it mean? If the message with VLAN 10, and I don't know, let's say we have PVID is going out from the gigabit 00, which is in the hybrid port. So the message will be forwarded with VLAN 10 because it's in the tag language. But if it's a message, let's say 99, then this will be untagged once sending because it's allowed, but it's an untagged range. So here in this kind of situation, we can transfer by untagged messages not only the PVID VLANs, but also any other many VLANs. Okay, so that's for that reason. Maybe in some cases, advanced cases, hybrid. It's better to use hybrid. But honestly, Cisco, for example, lives without hybrid port. It's up to you, I guess. Obviously, I don't know why, but Huawei decides to create the hybrid port as long as they're happy. Okay. Okay. So now let's go to our topic, which is a spanning tree protocol. So before talking about the spanning tree protocol, I'm going to tell you something. Okay. So I'm going to show you the picture. I'm going to open the new page and I'm going to say Cisco. So Huawei STP. So what's gonna? So I'm gonna tell you. Gosh. I'm gonna draw a picture of you. So for example, we do usually have some L3 switch. This is switch, but L3 switch, right? So I'm gonna call it L1. And then we do have a switch S1. And then we have multiple computers. So usually this is how our network works. And then maybe we have some additional devices out there. So let's say these computers, they wanted to connect to outside internet. They use this path. But what if in between L1 and S1, the link fails? Link failed. So what are we gonna do? So it means all of these devices that connected to this, they will call the network administrator and tell them, okay, so there's a problem, and they're gonna just kick his mind, so he's not able to solve this problem. But how we can solve this problem without make it seamless for end users? To solving this problem, it's simple, by providing some kind of backup devices. L2 like this, and we connect them. So now, if this link fails, it can find another path by this or this. Or, sorry, I think this, or this path, right? So this is a way. This is a solution of this problem. However, there's some problem with this kind of network. So now I'm going to tell you what is the problem with this. If we're going to make a lot of connection and we try to make the network reliable, there is a problem. And this problem is called L2 loops. So let's discuss frame. Before coming back to this problem, let's discuss the frame. Frame includes header. The header includes the information, the source MAC address and destination MAC address. And the message will end with the trailer or frame check sequence, something to checking the error. What is in between, it's called payload, and usually it's not looking, if we're forwarding the message, we are not taking a look for the payload. We are looking for the header, for the MAC addresses, and we send the message. Maybe if we look something, maybe we take a look for the IP addresses, which is in the payload also of the frame. But we only look for the source and destination MAC address. We're not going to look for the rest of the information when we forward the message. In this payload, we do have the IP header. IP header, besides the source and destination MAC address, somewhere there, it's called something called TTL. Do you remember what is TTL? Okay, it's time to leave. What is the purpose of the time to leave? Prevent loops. Exactly. Prevent loops. But here, this TTL is not working in L2 because it's inside the payload. Inside the payload. No one even looking for that, because we are deciding information where to send the message by looking for this header. We're not looking even the payload. But now this loop's gonna happen, and now let me explain how it's gonna happen. So imagine this computer A is sending the message, and this message is a broadcast message. So destination MAC address is FFFFFF, so on. It sends the message to S1. Where this S1 will send the message? Help me out here. It's a broadcast message. Destination address is broadcast. Да, верно. Всем отправляет. Всем отправляет сообщение. That's correct.